Hello, everybody. How are you? It is Wednesday evening, and I thought I would do this answer key with explanations. So I hope that you watched my 10-minute reteach of logistic diffie-Qs. Mason, you never wrote back and let me know if you found that video helpful when I wrote you back, and I also never saw you in office hours. So you just kind of left me hanging, wondering if you got that. Couple things, everyone. Let me tell you, when I looked at the work you handed in today, what a difference. Holy moly. I think that Tuesday, the work I got Tuesday versus the work I got Wednesday, it's like night and day. I was looking at your work on Wednesday, and collectively, here's my reaction. I was like, this is my class. They're back. I see them. So just a couple of reactions. Now, I mean, there are a few little things here and there that I would like to make sure I address with you individually or collectively. You can just always ask a question in class. But on the whole, everyone, I'm glad that we're finding, these little moments that we can grab that we do have some control over when the events outside of our houses we have very little control over. Sometimes moments like this are a little bit of a respite. I mean, I know it's a stretch to kind of get my head in that space sometimes, but whatever glimmers we can grab, we grab them, right? So I'm using Screencast-O-Matic, and I think you're on YouTube, and hopefully the audio here should be sheer melodic perfection. I hope you feel that way too. But I digress. Okay, I'm just going to go over this. This is first the logistic diffie-Q problem set, so please go ahead and yank your problem set out. So what I did here, and again, if you watched my 10-minute reteaching of it, this logistic diffie-Q stuff was a breeze, okay? So what I did for each of these diffie-Qs is I just factored each one, okay? And when I factored each diffie-Q, you can very clearly see where the horizontal asymptotes will be. You've got a horizontal asymptote at p equals 200 and a horizontal asymptote at p equals 0. And what that means is that if p equals 200, dp by dt should equal 0, and only this satisfies, only part A meets that criteria. Okay? All right, let's keep going. Whoop, hang on. Okay, and then number 14, which of the following is a logistic diffie-Q? Just remember, a logistic diffie-Q, it's always going to be quadratic in y, or the dependent variable. The number one careless mistake people would make is to pick C, but this diffie-Q here is quadratic in the independent variable, so the answer here is E. Okay, similarly, number 7, answer is E. That's a coincidence, they're both E, that's silly, okay? 21, moose. The plural of moose is not meese, as I like saying. I just like the word meese. Anyway, so here, this phrase is really important. Limit as t approaches positive infinity of m of t. What they're asking you for is that upper asymptote, that upper bound. And if you look at the diffie-Q right here, you will see that dm dt equals 0 when m equals 0 and when m equals 200. So m equals 200 is the upper carrying capacity. Number 7, Tyler Hart and I just discussed this one. And this is kind of one that I think I did longhand in my reteaching, but I also told you a shortcut. So this question is, what are all the values of y for which the population is increasing at a decreasing rate? They're asking you for when is dy dt positive and when is the second derivative negative. Okay, but I also told you here that for the logistic diffie-Qs that you are responsible for, that, I think I told you this, and when I was talking to Tyler, I realized I might have said it very, very quickly. That in this particular case, these are the asymptotes, right? These are the values where dy dt equals 0. Or where dy dt is approaching 0, okay? For us, this point of inflection is always going to be halfway, always. It will always be halfway between the two bounds, okay? And for us, the logistic Diffie-Q will always start concave up, inflection point, then concave down. So that will help you, okay? So where is dy dt positive and the second derivative negative? That is for values between 500 and 1,000. Oh, Shazbot, I colored the wrong one. Tyler, why do we have the other one? Increasing and a decreasing rate. I think we circled the wrong one. Anyway, okay, 84. I want to do this one with you guys live. Okay, so the max number of people allowed on the beach is 1,200. That tells me that the upper asymptote, P equals 1,200, is the horizontal asymptote up top, okay? This phrase right here, when P is 200, people are increasing at that rate. What this tells me is that when P equals 200, at that value, dP by dt is going to equal 400. So these two pieces of information are enough for us to knock things out, okay? So this criteria right here, if P equals 1,200, dP by dt has to equal 0. That knocks this guy out. Okay, unfortunately, it doesn't knock anything else out. Now we're just going to plug and chug. For which of these, when P equals 200, will dP by dt equal 400? And here is where I'm just going to do some quick mental math. It's obviously not this one. What is this one? 1,000 times a half. Is that right? Is this one? When you go look into here, this is 1,000 times a half. It's not this one. This is 1,000 times 2/5. What's 1,000 times 2/5? 5 goes into 1,000, 200. Oh, this is a potential one. And then, wait a minute. Okay, vamos. This is 1,000 times 2/5. And this gives me also 1,000 times 2/5. Wait a cotton picking minute. Hold on. Oh, but, silly yam. But this one doesn't have a lower asymptote at P equals 0. Dun, dun, dun. So the answer is C. 91, the number of students in a school. I also did this one live with you guys, okay? At noon, 50 of the school students have heard the rumor, also at noon. So again, when P equals 500, where am I go? Okay, when P equals 500, dP dt equals 20, okay? Let's see. We'll see which of the following could be the logistic Diffie-Q. So I'm looking at these. All of these are quadratic with P. Okay, at noon, 50 of the school's 500 students. Oh, wait a minute. I highlighted the wrong thing. Sorry. When P equals 50, dP dt equals 20. And this number tells me the upper asymptote. So P equals 500. Because that's the population of the school, that has to be an upper asymptote, okay? And that is the case for all of these. So then, which Diffie-Q tells us that when P equals 50, dP by dt equals 20. Okay. Oh gosh. Mental math. Which number is that? This is one that I would just quickly use a calculator for. I just have to plug these in. So can you plug those for me, kids? You guys, I mean, the point is you know how to do it now, okay? All right, now let's go to these answers and all the work, okay? Question 3 was really testing your keeping track of details. I mean, that's kind of calculus in a nutshell. I mean, that's really life in a nutshell, right? Okay. It's keeping the K's and the X's all clear. So if you kept the K's and the X's just clear in your head, it really wasn't that big of a whoopee. So part A is right here. Okay, part A. And, you know, just putting my work, making it really clear. Part B is right here. Really nothing juicy about question number 3. I think I know. I put it on here just because there was problem involving partial fractions in part D. But anyway, here's part B. And remember, they do ask you things like, justify, that kind of stuff. Okay. Part C, critical point. Critical point is when the first derivative is either undefined or equals to 0. Okay. And the value of k that makes f prime undefined or 0, if k equals -10, the numerator equals 0. And I just noted something, that if k equals -5, the denominator equals 0, right? Let me think about that. If k equals -5, okay? So I'm just going to investigate that. So what I'm going to do here is, let's see, f of x. So this is actually doing this with you guys live time. What f of x is this, right? Okay, so I got 1 over x times x minus k. So according to the function, x doesn't exist at 0 and x doesn't exist at k. Okay, so x can't be k, or k can't be x, right? That means when I look down here, and though I want to say k equals -5 is also a critical point, this criteria here tells me that that is actually not a viable option. Okay, that's it. Good. That was fun. So the only value of k that yields a critical point at x equals -5 is k equals -10. Oh, I love that. I love when I'm just throwing little curveballs, because, it just makes me makes me feel young, kids. Makes me feel young and frisky. Okay. Part D, here is 1 over x squared minus 6x. Factor the denominator, partial fraction decomp, multiply by the LCD. Here's the values for A and B. And here are your integrals that result from the decomposition. And just remember Mason and Bennett. And I know it's not just YouTube, but it's just the your work is just the most recent one that I saw that had this, right? Because you have 1 over a degree 1. Yes, you may go ln, go ln, go ln. Okay? Very good. All right, here's number 6. Just go ahead and take a look at the purple for a second. I just wrote the methods, okay? A and B are parts, and these are your choices of U and dV, okay? C is partial fractions. I didn't do any of those out. I didn't do out the ones I didn't think you need me to do out. Dirty trick is D. What's the dirty trick? So glad you asked. The dirty trick is this. This becomes the indefinite integral of x squared minus 4 plus 4 all over x squared minus 4 plus 4 dx. And then what you do there is you rewrite this as the indefinite integral of x squared minus 4 over x squared minus 4, which is just 1 dx, right? What? There's no plus 4 down there. Silly me. Okay. And then plus the indefinite integral of 4 all over x squared minus 4 dx. Okay. And then Mason and Bennett, no, don't do ln here. What you got to do with this integral now is what? Yes, this one is going to require partial fractions. Okay, and you say what you have to do is you have to decompose 4 over x plus 2 times x minus 2. You've got to decompose that. I'll put a ... so you can finish. Okay, very good. E, I said easy because it's just the ln. See, Mason and Bennett, right? This one would just be 2 times the natural log of the absolute value of x minus 5 plus c. Okay, and I kind of purposely did this. Like I purposely gave you rational function, rational function, rational function. Even here is a rational function, but not all of them have ln, right? Not all of them involve ln. Okay, F is semi-dirty. I said it's a semi-dirty. So look what I did to the radicand. I did this to the radicand. Then I popped the x squared out of the radicand. Then it's a basic u sub. and then dot, dot, dot. Okay. G is an improper. Okay, look at the red, improper. There's my rewriting as a limit involving B. And then just don't lose the absolute value here. And as B approaches 5 from the left, the argument of natural log approaches 0. Natural log of 0, remember? Okay, as the argument of ln approaches 0, the curve approaches the vertical asymptote. So this right there approaches negative infinity. So the integral diverges. H is another improper integral. Just look at the blue over there. Not a whole lot to add. I think I was pretty thorough. As B approaches positive infinity, this approaches 0, which is why the entire integral converges to 3/2. Okay? All right, everybody. Really great job. See you and talk to you soon. Goodbye.